Hello students, we are starting next topic, that is basic proportionality theorem. This theorem is also called the Thales theorem. You will not get this name in your textbook, but the Thales was a mathematician as famous as Pythagoras. Thales theorem or simply basic proportionality theorem. What is basic proportionality theorem? Proportionality. Suppose triangle ABC is given and segment PQ is parallel to BC. In this triangle ABC, segment PQ is parallel to BC. This is given. See, if line PQ is parallel to BC given, then AP upon PB is equal to AQ upon QC. This is the theorem. Don't worry, we are not going to prove it now. When we will prove it, that time I will show you. At present, we will call it a property. Property means we can use it for the example solving. So again repeating, triangle ABC is given, line PQ or segment PQ is parallel to BC, one of any side BC. Then AP upon PB is equal to AQ upon QC is true. Converse means opposite of this statement. Means if your parents are your parents, then you are their children. And converse, you are children, therefore they are parents. In the same manner, this sentence can be written as a converse. Converse means if lines are parallel, ratio are equal. If ratio are equal, then lines are parallel. Sometimes they will give you ratio, then you have to take out the conclusion lines are parallel. So this is main property. When line is parallel, ratio is equal. Opposite of that, converse is if ratio is equal, then lines are parallel. This is simple BPT or Thales theorem. We'll come across the example based on this in the next exercise. Now the next property. Next property is angle bisector theorem, a property. In this, they will give you an angle bisector of any triangle. Triangle PQR is given and suppose QS is an angle bisector. These two angles are congruent. So QS is an angle bisector. If QS is bisector of angle PQR, then ratio PQP upon QR is equal to PS upon SR. See what they have given. QS is bisector. In first condition they have given QS is an angle bisector. If it is an angle bisector, then this ratio is true. This ratio is true. This is simply called angle bisector theorem, या angle bisector property. How to prove? We will come across that afterward. First, you understood what is it. Now, again the converse. Converse means opposite statement. See, but if it is a bisector, ratio is equal. Now, if ratio is equal, the given ray is an angle bisector. Suppose QP upon QR is equal to PS upon SR is given. Then you can say certainly, fixed, you can say certainly QS is a bisector of angle PQR. So simply we can say, if the given ray is bisector, a ratio is equal. If given ray is a bisector, the given ratio is true. Yeah, given ray is a bisector, then the ratio is equal. Converse, if ratio is equal, the given ray is bisector. If ratio is equal, then given ray is a bisector. This is called converse. Main statement, converse. We are going to see examples of based on this in next exercise. So remember this very nicely. Now we are studying the third property, which is called property of three parallel lines and their transversals. Property of three parallel lines and their transversals. What is given? Line AB parallel to line PQ, parallel to line MN. Given things, line AB parallel to line PQ, parallel to line MN, and these two are transversals. APM and BQN are two transversals. Three parallel lines, two transversals. Then, if this is given, then a ratio AP upon PM is always equal to BQ upon QN. Say again, three parallel lines, two transversals. If these three lines are parallel to each other and there are two transversals making 1, 2, 3, 4 intercepts, then ratio AP upon PM is always equal to BQ upon QN. How to use them? We have studied three properties. One is BPT, that is Thales theorem. Second is angle bisector theorem. And third is parallel lines and their transversals. How to use them for solving the examples for the next exercise we are going to see. These are the basic properties. These are theorems, but at present I am calling it them as a properties. Since we are not proved yet, when we will prove it, that time you will get the idea how they have proved. So don't worry, theorem. So lot of people say theorems are important. First you understand the statements of theorem, you will understand how to solve the examples. Examples are maximum in the exam. Theorems are less. Maximum three theorems will be there for proving. So theorems can be studied, but after some time, when you get mastery on examples, you go for the theorems. This is my theory, and I will show you. For last 37 years, I have proved geometry is very easy subject by using the same technique. Don't worry regarding this. We are going to solve exercise numbers 1.2 very nicely. You will understand how to apply them. So we are starting exercise 1.2, first example. Out of that, first one, they have given one triangle PQR, plus they have given some measurements of sides, and now we have to decide whether the ray PM is a bisector of that triangle or not. Remember, ratio is same, the given ray is a bisector. That means converse. Ratio is same, the given ray is a bisector. So it is converse of angle bisector theorem we have to use. Let us see. Here PR upon RM is equal to 7 upon 3.5 is equal to 2 upon 1 is equal to 2. That is statement number 1. We have taken ratio. Next is PQ upon QM. It is 3 upon, PQ is 3 upon 1.5 is equal to 2. From 1 and 2, PR upon RM is equal to PQ upon QM. Reason, the answer of both ratio is 2. So ratios are equal, means the given ray PM is a bisector. Therefore, ray PM is a bisector of angle QPR by converse of angle bisector theorem. Angle bisector theorem. Very simple. If ratio is both ratios have same value, then the ray is called the bisector. It is converse. So we are using angle bisector theorem's converse property. Correct? Now we are going for second one. So students, we are starting second example, in which again triangle is given QPR. The ray PM is also again given, and the measurements are given. What we have to show now, find out now, the ratio of given sides. So PR upon RM is equal to 7 upon 6. Always PR upon RM. Next is this side, that is PQ upon QM. See, 7 upon 6 is a statement number 1. PQ upon QM is equal to 10 upon 8. That is also, when you cut it, even after cutting, the answer is 5 by 4. So these two ratios are not equal. From 1 and 2, ratio PR upon RM is not equal to ratio PQ upon QM. When ratios are not equal, the given ray is not a bisector. So, conclusion, a ray PM is not an angle bisector of angle QP. Very simple. The remaining examples you can do at your own. Now I am starting the second example of exercise 1.